Hi, curious conscience! In this video, I'll explain how humans have built science upon a narrow collection of metaphorical concepts. So, what's a metaphor? In a broad sense, a metaphor is to address some idea in terms of a different domain. For example, a space is an intuitive idea, but we define a space as the distance light travels in some time. Hence, we use time to understand a space. However, we use a space to imagine time as an arrow containing separated events, close or far from each other. Something similar happens with matter or mass. We understand material objects as stuff you can't see or touch, but we define sight and touch as a relation between objects. At the end of the day, mass is a mystery for physicists as touch is for psychologists. Furthermore, in the next chapter, I'll show how we define the mass unit from the time unit. However, we also say that mass warps space-time. So the most elemental physics concepts constitute a circular system of vague ideas. These space-time metaphors are fantastic for science. They allow us to organize our experience and predict the outcome of many experiments. That's why we have computers and vaccines. The problem came when some people forgot this circular nature. Then they presumed that space, time or mass existed before any subjective experience. In other words, they became radical Big Bangers. Here's how it happened. Practical people have always dealt with sort of round wheels and sort of a square farmlands. But as geometry evolved, storing and transmitting knowledge with examples about wheels and farmlands was annoying. Then a revolution took place: axiomatics. Axioms or postulates are intuitive statements you must accept without proof to derive other ideas, called theorems. Indeed, the axiomatic systems aim to obtain useful theorems from the least amount of presumptions. For instance, Euclid derived most of his epoch's geometry from a few axioms. One states that you can always draw a straight line from any point to any point. But what's a point? According to Euclid, it's something without parts. But then, what's a part? Euclid is losing his patience, but he suggests another intuition. The whole is greater than the part. Then you, the first in pondering history, think out loud. We use the word universe for the greatest whole we can imagine. Still, the universe's bricks are more like relations than truly individual parts. So we need a reference to say if things are greater or smaller than Euclid's point. After all, wholes might be smaller than parts. That's how the first in pondering history was expelled from geometry classes. Unfortunately, the situation has stayed the same for 2300 years. Today, geometry, numbers and logic, the principal tools of science, rely on set theory. It's an axiomatic system whose crucial intuitive concept is the set, a vague idea of wholes containing parts. For example, number 1 is a set containing the empty set. Number 2 is another set containing number 1 and the empty set, and so on. This way, a practical but tricky concept conditions how we understand our spatial, temporal and material experiences. That's why we imagine a universe containing bodies, bodies containing molecules, and molecules containing atoms. Still, science allows an alternative language to imagine parts holding wholes. It's harmony or complexity. So in the following chapter, I'll show how physicists have discussed harmony as a time unit. Thanks for watching.